Have you ever looked up at the night sky and wondered what secrets the universe is hiding? We see stars, planets, and galaxies with our eyes. But what about the things we can't see? Today, we are rediving into the story of one of the most powerful and invisible forces in the cosmos. Gamma rays. And it all starts not with a brilliant astronomer in an observatory, but with a quiet, unassuming French physicist named Paul Villard. The year is 1900. The scientific world is buzzing with excitement over a recent discovery. Radioactivity. Scientists like Henri Becquerel and the Curies, Marie and Pierre, had found that certain elements, like uranium and radium, spontaneously emitted mysterious rays. They identified two types: alpha rays, which were heavy and positively charged, and beta rays, which were light and negatively charged. It seemed like they had cracked the code of this new phenomenon. But Paul Villard, working with radium in his Paris laboratory, suspected there was more to the story. Villard was a meticulous researcher. He designed a clever experiment. He took a small sample of radium and placed it inside a lead container with a narrow opening. This created a beam of radiation. He then passed this beam through a magnetic field. As expected, the alpha rays bent one way, and the beta rays bent the other. But something astonishing happened. A third type of radiation passed straight through the magnetic field, completely undeflected. This meant it had no electrical charge. Not only that, but this new ray was incredibly penetrating, able to pass through thin sheets of lead that stopped the other two. Villard had found something new, something powerful. Ikadetam simply, extras from radium. But he knew they were different. For a few years, Villard's discovery didn't make huge waves. The scientific community was still focused on understanding alpha and beta rays. It wasn't until 1903 that the famous Ernest Rutherford, the father of nuclear physics, took a closer look. He confirmed Villard's findings and realized these rays were a fundamentally new type of radiation. He was the one who gave them their now famous name, gamma rays, using the third letter of the Greek alphabet after alpha and beta. So, what exactly had Villard and Rutherford uncovered? They had found the most energetic form of light in the entire universe. Gamma rays are a type of electromagnetic radiation, just like the visible light from a light bulb, or the radio waves that carry your favorite music. The only difference is their energy. A single gamma ray photon can carry millions, even billions of times more energy than a photon of visible light. This is why they are so penetrating and, as we would later learn, so potentially dangerous. They can zip through solid objects, interacting with matter on a subatomic level. But the story of their discovery on Earth was just the beginning. The real mystery was, where did these incredibly powerful rays come from in the vastness of space? For decades, this remained a puzzle. Our atmosphere is a fantastic shield. It absorbs incoming gamma rays, protecting life on Earth. This is great for us, but it meant that to study cosmic gamma rays, we had to get above the atmosphere. Fast forward to the Cold War era, the late 1950s and 1960s. The United States and the Soviet Union had signed the Partial Nuclear Test Ban Treaty, which prohibited nuclear weapons tests in the atmosphere, in space, and underwater. How could they be sure the other side wasn't secretly testing nukes in space? The US launched a series of satellites called the Vela satellites. Their mission was simple: to detect the telltale flash of gamma rays that would be produced by a clandestine nuclear explosion. The satellites orbited the Earth for years, silently watching. And they did see flashes of gamma rays. But these flashes weren't coming from the Earth. They were coming from deep space, from random directions. And they were incredibly brief, lasting from a fraction of a second to a few minutes. They were completely unlike anything expected from a nuclear weapon. For several years, the scientists at Los Alamos National Laboratory who analyzed the data were stumped. They were so concerned about the political implications that they kept their findings classified. Was it some new Soviet technology? An alien signal? The possibilities were mind-boggling. Finally, in 1973, after years of careful analysis, the team published their findings. The secret was out. The universe was peppered with mysterious, mind-bogglingly powerful explosions they called gamma ray bursts, or GRBs. This discovery opened up a brand new field of science, gamma ray astronomy. We had a new window into the most violent and energetic events in the cosmos. So what are these gamma ray bursts? Astronomers now believe they are the birth cries of black holes. They can be triggered in two main ways. The first is a hypernova, which is what happens when a truly massive star, maybe 20 or 40 times the mass of our sun, runs out of fuel and its core collapses. This collapse is so catastrophic that it forms a black hole, and in the process, shoots out jets of material at nearly the speed of light. When we happen to be looking right down the barrel of one of these jets, we see an incredibly bright flash of gamma rays. The second cause is even more spectacular. The collision of two neutron stars. Neutron stars are the ultra-dense remnants of smaller, massive stars. Imagine two objects, each with more mass than our sun, crushed into a sphere the size of a city, spinning hundreds of times a second and hurtling towards each other. When they finally collide and merge, the resulting explosion, called the kilonova, creates another burst of gamma rays, and, as we discovered in 2017, also sends out ripples in spacetime known as gravitational waves. These events are the most powerful explosions in the universe since the Big Bang. A single gamma ray burst can release more energy in a few seconds than our sun will in its entire 10 billion year lifetime. They are so bright that we can see them from across the observable universe, making them beacons that allow us to probe the very distant, early cosmos. From a quiet lab in Paris to top-secret Cold War satellites, the discovery of gamma rays is a perfect example of how science works. A curious mind observes something unexpected. Others build on that work. And technology designed for one purpose opens up a whole new universe of questions. Today, telescopes like NASA's Fermi Gamma Ray, Space Telescope, and the Swift Observatory continue to scan the skies, catching these fleeting bursts and helping us piece together the story of the most extreme events in the cosmos. So, the next time you look up at the seemingly peaceful night sky, remember that it's alive with invisible fireworks of incredible power. The legacy of Paul Villars' careful experiment continues to unfold, revealing a universe that is far more violent, dynamic, and fascinating than we could have ever imagined. Thanks for joining me on this journey through the invisible universe. If you enjoyed this and want to learn more about the amazing secrets of the cosmos, make sure to hit that like button and subscribe for more deep dives into science. Until next time, keep looking up.